Welcome back, chemistry fans. Today, what we're going to do, I'm running out of fingers. This is Unit 9, Topic 1, homework. Let's jump into it. This is dealing with our new unit, all about intermolecular forces and how we can predict some of the properties from them. So first question here asks, what causes dipole-dipole intermolecular forces? So I am going to scroll down here and talk about dipole-dipole. So dipole-dipole means that we have some molecule that has a dipole. Now, we talked a couple of units ago, what causes dipoles is this unequal sharing. So it's basically polarity. So if I have a molecule, and what you would notice is it's not symmetrical top to bottom. Left to right it is, but on top to bottom it is not. So what we have is this more centered, that there are more electrons pooling down on this half of the molecule. So what we would have is this dipole force down here being mostly negative and a dipole up here being mostly positive. Okay, so that means then this negative side would attract to a positive side. So if we were to stack this, then what we could have is two molecules that would continue to stack because we would have a positive and a negative that would attract together. The way that we show this attractive force is generally with a dashed line in between the molecules. So question is, what causes dipole-dipole intermolecular forces? Well, it is the attractive forces between polar molecules. So the positive dipole side attracts to the negative dipole side. Put that into your own words. Number two, what causes a hydrogen bond is between hydrogen and one of three different molecules, N, O, and F. So again, this is essentially a hydrogen bond that I have drawn over here. But if we were to draw this more specifically, how we could reference this is I could have hydrogen, which is much, much, much smaller than the fluorine is, and it would then be attracted to another molecule over here because there's such a discrepancy, such a difference in their charges because of this size. So we could have another fluorine over here if you want bonded to a hydrogen. So it would be basically the same idea as what the dipole-dipole is. The only key is, though, it's between three specific atoms, three specific elements, nitrogen, oxygen, and fluorine. But it works the same way as a dipole-dipole. So it's the unequal attractive forces between molecules that have elements nitrogen, oxygen, and fluorine. Okay, dispersion now is specifically different. So this one does actually look a little bit different whenever we draw it out. Dispersion forces are the movement of the electrons. Now, this can happen even in nonpolar molecules. So if I have some temporary time where all of the electrons pool over here on one side, and at the same exact coincidental moment, all of the electrons in the other atom happen to be on this side, well, now I have a temporary negative side, and I have a temporary negative side on this atom, but over here, I have a temporary positive. So this is dispersion. It's just the movement of electrons, which causes these temporary dipoles. This is not based on size. This is not based on structure. This is only based on the movement of the electrons. So as quickly as the electrons move to one side, there are attractive forces. But when the electrons move to the other side, those attractive forces are over. All right. How do intermolecular forces cause changes in boiling points? Well, if we have attractive forces, they hold molecules together, which means we're going to have a higher boiling point. Because if these atoms are close together, they don't become gases. So if we have gases, the particles are further apart. But if you have them as liquids, well, the atoms are closer together. The closer they are, the higher the boiling point. Whoops. Yeah, nice boiling point. All right. What causes intermolecular forces to change the viscosity of a liquid? Well, it's the exact same story. Instead of it changing, so they hold molecules together, and that increases viscosity. Viscosity is a resistance to pouring. It's a resistance to deforming. So if I have particles that stick together, they do not want to become a thin line that pours out. If you have a bunch of molecules that are far apart, well, it's easier for you to pour them out. So this one has higher intermolecular forces. This one has low intermolecular forces. IMF, not IN, IMF. Okay, so the stories are all basically the same. The closer the particles are, the higher the boiling point. The closer the molecules are, the higher the viscosity, the resistance to being poured out. The closer they are, the stronger the molecules are as far as their intermolecular forces. So the dipole is the hydrogen bonds are the strongest intermolecular forces. Dipole is second, and dispersion are the weakest of the intermolecular forces. Okay, this is everything that I wish to share with you. Thank you so much. Talk to you again soon. Bye-bye.